Geometry review for the pending exam on December the 11th. In slope-intercept form, write the equation of the line that is shown. The hint is that we have y equals mx plus b. That's the format that we're wanting. We want that format right there. Click on the stop sign right here. That'll pause the video. You can try to work it out. Then you come back along and you click on the go sign, and I'll show you it worked out. Click on the stop sign. All right, let's see how you did. Well, if you have the format y equals mx plus b, that's what we're looking for here. So our m value is just rise over run. So we take a look at what a rise is. 1, 2, 3, 4, 5, 6, 7. And our run is 1, 2, 3, 4, 5, 6, 7. We can count that, or we could do the math here and say that we're down 6, and then we come up 6, and then an additional 1. That's 7. So you could do the math, or you could just count. And so our rise over run is 7 over 7. And that is, both of those are positive numbers. So we wind up with our m value as being 1. The 1, we don't have to bother writing the coefficient of x on that. So we have y equals 7 over 7x minus 8 because we cross the y-axis at negative 8. And so you wind up with y equals x minus 8. So if you got y equals x minus 8, you're doing it right. Okay, let's take a look at the next one. You'll click on the stop sign and see if you can work out the problem, then click on the go sign and come back and take a look at how you did. All right, let's see how you did. It says in slope-intercept form, that's the y equals mx plus b, write an equation for the line that is perpendicular to the blue line and passes through the point 5, 5. So we want something that passes through that point right here. And it's going to be perpendicular, so that means it's going to be 90 degrees to this right here. So automatically you know that I'm dealing with a negative slope for my blue line, and this additional line that I have over here is going to have a positive slope. And so let's take a look at how you did. Well, turns out that y equals a rise of negative 5. If I'm here, I would start by going down in the negative direction, so I would go down negative 5, and then I would go over 10. And that's a positive number, so I'd go down negative 5, or I could start here and go over, that's a positive 10, and then go down negative 5 here. It doesn't matter where the negative sign is. So I have y equals negative 5 tenths x, that's my m value, plus 1. 1 because that's where I cross the y-axis, and simplify all that, and I get y equals 1/2 x plus 1. But that's only the first step. That's me getting the information on this line here. But the question was, what about if we had a line here? Well, if I have a perpendicular, a couple of things happen. I know that the sign changes. So I went from a negative here to a positive down here. So my m value changed in sign from a negative to a positive. And I was 1/2. But what happens when I have a perpendicular is that the numerator becomes the denominator and the denominator becomes the numerator. So instead of 1/2, I have 2 over 1, and 2 over 1 simplifies to 2. So the slope of the line here, the equation for the slope of the line that is perpendicular to the original line would be y equals 2x minus 4. Now, how did I get the minus 4? Well, let's take a look at this, get rid of some of this stuff here. And, whoops, didn't want to erase all that, but I did anyway. So, all right, how do I get the minus 4? Well, we started here, and I have a slope of negative 2, so I go down 2 over 1, 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 and that's where I would cross at negative 4. 1, 2, 3, 4. Okay, let's work the next one. In slope-intercept form, write the equation of a line that is parallel to the line shown, that'd be this line right here, and passes through the point 0, 1. Click on the stop sign, give it a whirl, and then come back and see how you did. All right, let's see how you did. Well, we're talking about a line here, so the first thing we need to do is find out its equation. What we know about lines that are parallel to each other is they have exactly the same slope. So my information, my equation for this line right here is y equals 7 over 7, a rise of 7 over a run of 7, x minus 8. Minus 8 because that's where it crossed the y-axis. So we have 7 over 7 simplifies to 1. The 1 just goes away as the coefficient of x because it just becomes x minus 8. But now we're talking about having a line that has the same slope but passes through the y-intercept at 0, 1. And that would be y equals x, the same slope, plus 1, which is where it crosses the y-intercept. Okay? Let's see. Write the equation of a line that has a slope of 3 and passes through the ordered pair 1, 1. The point slope form is y minus y sub 1 equals m, then open the parentheses, x minus egg sub 1, close the parentheses. Well, the nice thing about formulas is you just plug in the numbers and then you follow the rules of the orders of operation. So click on the stop sign, give it a whirl, then come back and see how you did. All right, let's see how you did. Well, we have y minus y1 equals m, and then in parentheses x minus x1, close the parentheses. So we just plug in the numbers that we have, and the numbers that we had were we're passing through this point right here of 1, 1, and so we stick those numbers in and then just solve. So and then you put it into this form right here, and that's as far as that I ask you to get. Y minus 1 equals 3 times x minus 1, close the parentheses. Now that you have written this in point-slope form, turn it into slope-intercept form. So turns out that to turn it into slope-intercept form, you just kind of come in and you say, well, I have the form that I had here, y minus y sub 1 equals m, parentheses, x minus x sub 1, close the parentheses. So we wind up with y minus 1 equals 3 times x minus 1. So click on the stop sign, give it a whirl. All right, let's see how you did. Well, turns out there's the line that we need. And all I'm going to do is just solve for y. So I'm going to first distribute my 3. So 3x is just 3x, and 3 times minus 1 is minus 3. So I wind up with y minus 1 equals 3x minus 3. Then I'm going to move the negative 1 to the other side. So if I add 1 to each side, this just goes away, and the negative 3 becomes a negative 2. So I wind up with y equals 3x minus 2, and I have the slope of the line here. It's a positive 3, and I'm crossing at negative 2. All right, find the equation of the straight line that has slope m equals 4 and passes through the point, our ordered pair, of negative 1, negative 6. Click on the stop sign. Okay, let's see how you did. Well, we know our m value is 4, and we know that it passes through the point. That is, our slope is a positive slope of 4, so it's going to be a slope of about like that. And it passes through negative 1, negative 6. So we simply just take our y and we plug it in, and we take our 1 and our negative 1 and we plug that in, and now we have y minus 6. That's the same thing as y plus 6, and then we have 4 x plus 1. We got the plus 1 because we have x minus 1, and that becomes x plus 1. Now we distribute the 4, so we have 4x and plus 4. So we wind up with y plus 6 equals 4x plus 4. And then we group like terms. So if we add a 6, or subtract a 6 from each side, this 6 just goes away and we're left with y on one side, and we're subtracting a 6 from the other side. 4 minus 6 is negative 2, and we wind up with y equals 4x minus 2. Here's the slope of our line over here, and we see that our line does pass through the point of negative 1, negative 6, and the slope of our line is a positive 4. All right, triangle ABC is a sketch of a scalene triangle. Angle A is 30 degrees, angle B is 95 degrees, and angle C is 55 degrees. Now this is a sketch, so it's not a perfect drawing. So if you were to come over here and measure this, you might find that it's not perfectly 30 degrees. But that's what the sketch tells us. Put lines X, Y, and Z, this is X, this is Y, and that's Z. Put lines X, Y, and Z in order from shortest to longest. Click on the stop sign if you need to. All right, let's see how you did. Well, it turns out that Y is going to be our shortest. It's our shortest because it's opposite the smallest angle. And our next one is going to be X, and it's X because it's opposite. See over here it's opposite the 55 degree angle. And Z is going to be our longest line, or longest side of the triangle, because it's opposite the largest angle. And the largest angle in this case is 95 degrees. So if you got Y is less than X, which is less than Z, you did it right. In the sketch below, we've got some problems here, so click on the stop sign, try to work it out, and then when you're frustrated or you think you have the right answer, come back and see how you did by clicking on the go sign. All right, let's see how you did. Well, we have some lines here, A, B, and C, that are perpendicular to line D, and they are also then parallel. And it also means by them being perpendicular that this is 90 degrees here, and that would be 90 degrees here, and this would be 90 degrees here. And we know that this is 5,000 meters, and we know that that's 2,000 meters. Obviously, this is a sketch and not drawn to scale. And so if that's 5,000 meters, we can then know that that would be 5,000 meters, and we can know that that would be 2,000 meters. So this would be 2K for 2,000, and this would be, that's the same right here. So we have two proportional triangles. So it turns out that if we took a look at this and we said, all right, we have this proportional triangle here, and that proportional triangle is proportional to this triangle here, we have some known sides, and that is, we know that that's the length of the hypotenuse, and that's the length of the leg, and we know that's the length of the hypotenuse. We know that this is the length of the leg. It's the length of the hypotenuse over here that we're trying to find. And we can do that by cross multiplying. So 5,000 times 2242 meters is the same thing as X times 2,000. And it turns out that we have 11,200 K equals X times 2K. Solve both sides for our, get rid of the 2K, and we wind up with X equals 5,650 meters. And we ask ourselves, does that make any sense? Well, yes it does, because what's happening here, you'll look at this, if this is 5,000 right here, and this is the hypotenuse, we know that the hypotenuse is always the longest line in a right triangle, and we have a right triangle here. So if this is 5,000, it makes sense that our answer is slightly more than 5,000, 5,605 meters. If you got that, you're doing it right. Okay, are the two triangles similar or proportional? Now that's not asking you are they similar or are they proportional. It's asking you if they're similar or proportional, which that's the same thing. If something's similar, it's also proportional. Well, no, these two are not. There's just not enough information. They could be similar or proportional, but we don't have enough information. We only know that they're two right triangles. Are the two triangles similar or proportional? No, they're not. Or they could be, but we don't have enough information. The only thing that we know here is that this angle right here is the same as this angle over here. That's the only thing we know. So we don't know if they are similar or proportional. So there's not enough information. Are these two triangles similar or proportional? Well, turns out there are a couple of things that we can know here. we know that this angle right here is the same as this angle right here. And we know that the length of this side is the same as this length over here. In other words, this line right here is congruent with that line right here. So all we know is that we have a side that's the same length, and we know that we have an angle that's the same. That's not enough information for us to determine whether or not that they are proportional. If we had something that looked like this, then yes, we could know that. But we don't know what the length of this line is, and we don't know what the length of this line is. We don't know what the length of this line is, and we don't know what the length of that line is. So, no, the two triangles are not similar or proportional to the best of our knowledge. Are the two triangles similar or proportional? Well, turns out, yes, they are. This sign right here means that it's parallel to this one right here. And so if we have this line being parallel to this line right here, we wind up with proportional triangles. Are the two triangles similar or proportional? Well, it looks like they could be. We have 4 inches to 8 inches as 8 feet to 16 feet. So we look at it and think, well, the ratio gives us the same. So this would be, we could say that the ratio is 1 to 2, and the ratio over here is 1 to 2, because the feet would cancel with the feet, and the inches would cancel with the inches, and we just have the pure number 1/2 and 1/2. But we don't know what this angle is, and we don't know what this angle is, so therefore we don't have enough information to know whether or not these are proportional. We just don't know what the length of this side is. If, however, we knew what this angle was, and we knew that it was congruent with this angle here, we would be able to say yes, but the original drawing didn't show us that. Are these two triangles similar or proportional? No, there's just not enough information. They could be, but we don't have enough information. Are these two triangles similar or proportional? Well, turns out that yes, they are. We know that this angle here is congruent with this angle here, and we know that the relationship of the length of this side to the length of that side is 1/2 to 1/2. Half of 19 is 9.5, so our relationship here is 1 to 2, and our relationship here is 1 to 2. Inches cancel out. The fact that these are in inches and these are in centimeters isn't a big deal. It's the relationship of the length. And so, yes, these two are similar or proportional. Which sketch below is similar to the one on the Cartesian coordinate system? In other words, this puppy right here is similar or proportional to A, B, C, or D below. Which one is it? Click on the stop sign if you need to pause. Okay, let's see how you did. Well, it turns out that the correct answer is A, because we have 4 units here and we have 4 units here with regard to its height or its altitude. And so our relationship of 1 to 1 is held, so A is the correct answer, not B, C, or D. I would sure hope that you wouldn't even consider D, but some people might. All right, let's take a look at congruent versus similar or proportional. Is the blue one congruent or similar to the purple one, and where does the green one fit into all this? Well, it turns out that congruent means the same shape or size. Shape and size, excuse me. So that means that the blue one and the purple one are congruent. They're the same shape and they're the same size. While similar or proportional means that the two have a constant ratio. And so what we're dealing with here is that they have the constant ratio. Let's say that the radius here of 2 and the radius here of 1, and then we could look at the circumference. We could look at the circumference. They have the same ratio of that. They have the same shape, but they're a different size. So therefore, they are similar or they are proportional, but they are not congruent. The shapes shown below that are the same color are similar, or they are proportional. In other words, this, and this are similar or proportional. They're not congruent. This and this are similar or proportional. They're not congruent. This and this are similar or proportional. They're not congruent. You get the idea. If you need to look at this any longer, you can just click on the screen anywhere and it'll pause. If you have questions or comments, please come see me before the exam or send me an email at alanmorris@yahoo.com.